So in this video, we're going to look at naming and writing formulas with transition metals. Well, first of all, what is a transition metal? Well, that's a great question. Let's take a look at the periodic table. So transition metals are pretty much these metals that we've ignored in the D block. All right, we haven't really specified how many valence electrons that they have, and we've just kind of pretended like they haven't been there on the periodic table. So now we're going to deal with these transition metals in terms of formula writing and naming. So as I mentioned, transition metals are in the D block. They have multiple oxidation states. Oxidation states show the number of electrons which may have been removed from an element. The 4s and 3d orbitals are very similar in energy, so electrons can be easily lost from either orbital. All right, so here are some examples. We have iron, and in my first iron here, notice I have 8 electrons. Here is iron with a +2 charge, so obviously here we would have 2 less electrons. So if you do some math here, let's see, we had 8 electrons in this first one. This is 6 electrons. And then here we have iron with a +3 charge, so that would mean that we have 5 electrons. And if you look at these 3 examples, you'll see that all of these kind of match up here. So 8 electrons, you can see them, they are listed right here. We have 6 electrons listed here, and then we have our 5 electrons listed here in the d orbital. All right, so let's go through our naming rules. We have some exceptions. We always have exceptions, right? So we've got tin. Tin and lead will have multiple oxidation states. Zinc is always going to have a +2 charge. Cadmium is also always going to have a +2 charge. And silver will always have a +1 charge. All right. And when we go to write out our formulas, these are our rules. The cation comes first, followed by the anion. That's always the same. We're going to use Roman numerals to indicate the charge of the cation. So if you're not familiar with Roman numerals, 1 is written as just I, 2 is written as 2 I's, 3 is, you guessed it, 3 I's, and then when we write 4, 4 is, of course, an exception. It's going to be IV. Next, we're going to determine the ratio of ions needed to make a neutral compound. And then, if we need to, we're going to reduce our ratios to the simplest form. All right, let's look at an example. So our first example is iron 3 sulfide. All right, so sulfide is sulfur, and sulfur has a charge of -2. We know from the 3 here that this is going to be iron, and it's going to have a charge of +3. That's what the Roman numerals tell us. And because we have a 3 and a 2 here, we're going to need to find the least common multiple, which is going to be 6. So this will be written as Fe2S3. So our iron will have a +6 total charge, and then our sulfur will have a -6 total charge. They balance out. All right, here's another one. Iron 4 oxide. So the oxide is oxygen. Oxygen has a -2 charge. Iron 4 will be Fe with a +4 charge. So when I write this out, it will be Fe. I'm going to need 2 oxygens to cancel out with the +4. So it'll be FeO2. All right, next we have manganese 2 nitrate. So nitrate is going to be NO3, and it has a -1 charge. Manganese 2 is going to be Mn with a +2 charge. So our cation goes first, manganese. Now I'm going to need 2 of these nitrates to cancel out. So if you remember, our polyatomics go in parentheses. And then if I need 2 of them, I'm going to add a subscript 2. All right, here's another one, iron 2 sulfate. So sulfate is SO4 with a -2 charge. Iron 2 will be Fe with a +2 charge. Fortunately, these are going to cancel out. We don't need multiples. So this will just be written as FeSO4. Right, now let's do the opposite. So now we're going to do some naming. Just like before, the cation comes first, followed by the anion. We are never, ever going to change the name of the cation. We're going to add Roman numerals in parentheses to indicate the charge of the cation. And then finally, for the anion, we're going to follow the monatomic or polyatomic ion rules. So let's do some examples. CuSO4. So Cu is copper. Copper is a transition metal. So we don't know the charge. We're going to have to specify the charge. Sulfate is SO4. So our first rule, cation goes first, so copper. Sulfate has a charge of -2. So for this to work out, we're going to need copper to have a +2 charge. So in parentheses, I'm going to write a Roman numeral 2. I want this to be copper 2, and then sulfate. All right. Next, we have FeO. So Fe is iron. Iron is a transition metal. We don't know the charge. O is obviously oxygen. Oxygen has a charge of -2. Iron, we don't know the charge. So to cancel out with our -2, this is going to have to be iron 2. And if you recall, oxygen is not polyatomic, so we are going to change the end. Now, oxygen is one of those goofy ones. This is going to be oxide. Iron 2 oxide. All right, here we go. Ni is nickel. Nickel is a transition metal. And then we have NO3. But if you notice, we have 2 of them. So NO3 is nitrate. Nitrate has a -1 charge, but there's 2 of them. So that gives us a total charge of -2. So nickel is going to have a charge of +2 to cancel this out. So this will be nickel 2 nitrate. All right, we got one more here. Name the following compound. We have SN and then S2. All right, well, SN is tin. Tin is a transition metal. And then we have sulfur. Sulfur by itself has a charge of -2, but there's 2 of them. So we'll have a total charge of -4. So to balance out the charge of -4, this will have to be tin 4. And then sulfur, we're going to change the ending. So it's going to be sulfide, tin 4 sulfide. And there you go. That's how you do naming and formula writing for our transition metals.